Is Python memory safe? With Dino being the new Node.js rival and all, the memory-safe nature of Rust has been mentioned in a lot of news articles. One particular piece stated Rust and Go are good for their memory-safe nature, as are Swift and Kotlin, but the latter two are not used for systems programming that widely. Safe Rust is the true Rust programming language. If all you do is write safe Rust, you will never have to worry about type safety or memory safety. You will never endure a dangling pointer, a use after free, or any other kind of undefined behavior. This piqued my interest into understanding if Python can be regarded as memory safe, and if yes or no, how safe or unsafe? From the outset, the article on memory safety on Wikipedia does not even mention Python, and the article on Python only mentions memory management, it seems. The closest I've come to finding an answer was this one by Daniel. The Wikipedia article associates type safe to memory safe, meaning that the same memory area cannot be accessed as, for example, integer and string. In this way, Python is type safe. You cannot change the type of an object implicitly. But even this only seems to imply a connection between two aspects, using an association from Wikipedia, which again is debatable, and no definitive answer on whether Python can be regarded as memory safe.
Wikipedia lists the following examples of memory safety issues. Python at least tries to protect against these. That's actually not that hard to do in languages with mutable data structures. Advocates of functional programming and immutable data structures often use this fact as an argument in their favor. There's no real way to prevent someone from trying to access a null pointer. In C# and Java, this results in an exception. In C++, this results in undefined behavior. Memory leaks in languages like C#, Java, and Python have different meanings than they do in languages like C and C++, where you manage memory manually. In C or C++, you get a memory leak by failing to deallocate allocated memory. In a language with managed memory, you don't have to explicitly deallocate memory, but it's still possible to do something quite similar by accidentally maintaining a reference to an object somewhere even after the object is no longer needed. This is actually quite easy to do with things like event handlers in C# and long-lived collection classes. I've actually worked on projects where there were memory leaks in spite of the fact that we were using managed memory. In one sense, working with an environment that is managed memory can actually make these issues more dangerous because programmers can have a false sense of security. In my experience, even experienced engineers often fail to do memory profiling or write test cases to check for this, likely due to the environment giving them a false sense of security. Stack exhaustion is quite easy to do in Python too, for example with infinite recursion. Still quite possible. I'm rather embarrassed to admit that I've personally done that in C#, although not in Python yet. Unwanted aliasing is actually quite easy to do in Python. Here's an example in Java. Full disclosure, I wrote the accepted answer. You could just as easily do something quite similar in Python. The others are managed by the Python interpreter itself. So, it would seem that memory safety is relative. Depending on exactly what you consider a memory safety issue, it can actually be quite difficult to entirely prevent. High-level languages like Java, C#, And Python can prevent many of the worst of these errors, but there are other issues that are difficult or impossible to completely prevent.
Y si no te gusta, pide curiosidad.